Today's lesson is on elimination with systems of equations. The first thing I want to discuss with you is that when we're doing systems of equations, we have to first eliminate one of the variables. It doesn't make any difference which variable it is. The most convenient one is the one that you want to get rid of. All right, so let's look at the first equation. I have x plus y equals 7 and negative x plus 2y equals 2. When I add these two together, I get x minus x as 0x, y plus 2y is 3y, and 7 plus 2 equals 9. Now, of course, we do not need to write 0 times 7 because that's 0. So all we have to do is to really eliminate that, bring down to 3y equals 9, divide by 3 on both sides, and we end up with y equals 3. Now what we're going to do is we are going to replace the y with 3. Either one, it doesn't make a difference. I like using positive numbers, so I'm going to rewrite x plus, I'm going to put the 3 in for y equals 7. Subtracting 3 on both sides, we end up with x equals 4. So the answer or the solution to this systems of equations is 4, 3. And I'm going to write 4, 3 down here so it doesn't get mixed up with my next problem. All right, you'll notice here, this time I have a 3y and a negative 3y. So again, I'm going to just add these two together. X plus 2x is 3x. 3y and negative 3y is 0. And then we're going to set this equal to 5 plus 1 is 6. So dividing by 3, again on both sides, we end up with x equals 2. Putting the 2 back into one of the equations, this is the simplest one. So 2 plus 3y equals 1. I subtract 2 from both sides. I end up with 3y equals negative 1. Dividing by 3 on both sides, we get y equals negative 1/3. So the answer to this systems is going to be x is 2 and y is negative 1/3. Now, this is a much better way of finding the solutions to systems of equations than it is to graph, because now we're getting the exact amount. I prefer this method over substitution because it's a little bit easier and there's not as much math. All right, in the next systems of equations, I have 2x plus 2y equals 6, and I have x plus 3y equals 7. Now here, like these, I do not have something that I can eliminate right off. So I'm going to have to manipulate one of the equations so that I can get rid of one of the variables. In this case, since I have a 2x and an x here, it would be easier just to multiply this by negative 2. When I do, I end up getting a negative 2x. Negative 2 times 3 is negative 6y. And negative 2 times 7 is negative 14. Every single term must be multiplied. Distributed property. All right, we're going to bring this down here. So I have 2x plus 2y equals 6. I'm going to add these together. This goes away. So I end up with negative 6 plus 2, which happens to be negative 4y, equals 6 minus 14. And that gives us a negative 8. I divide by negative 4 on both sides, and we end up with y equals 4 into 8 is 2. Remember, a negative divided by a negative is a positive. Now, I'm going to go ahead and put my 2. It doesn't make any difference. I'm going to go ahead and use this one. So I'm going to have x plus 3 times 2 equals 7. 3 times 2 is 6. So x plus 6 equals 7. Subtracting 6 from both sides, we end up with x equals 1. So the solution to this system is going to be 1, 2. Next, here I have y equals x plus 13 and 2y plus 7y equals 10. Here they ask you to choose a method. You can either choose elimination or you can choose substitution. I prefer elimination. If you want to do substitution, that's fine. You would put x plus 3 in for y, solve for x, and then put it back into one of the equations. I prefer to rewrite this as negative x plus y equals 13. I have a 2 here. I have a negative here. So it would just be easiest to multiply everybody by 2. So I end up with negative 2x minus 2y equals, negative 2x plus, be careful, 2 times that is negative, that's positive, and 2 times 13 is 26. Now I'm going to bring this down here, so I have 2x plus 7y equals 10. Again, we add, so we end up with 9y equals 36. Dividing by 9 on both sides gives us y equals 4. Taking our 4, putting it back into either one of these equations, I'm going to use this one. So we have 4 equals x plus 13. I subtract 13 from both sides. And we get negative 9 is equal to x. So the answer to our systems here is going to be negative 9, 4. The last systems that we're going to do requires, again, changing one of these. You have to decide which one you're going to change. I'm going to take and multiply this up here by 2. When I have to multiply it by a negative 2, because I have a negative 4 here and I need a positive up here. So negative 2 times 8 is negative 16x. Negative times negative is a positive, 4y, and negative 2 times negative 8 is positive, 2 times 8 is 16. Now, I don't need to rewrite this. I'm just going to go ahead and use it from there. If you use this one and bring it under here, you can just use that the way it is. All right, here we go. This cancels, so we have negative 16 plus 5 is negative 11x. That cancels out to 0. 6 plus 16 is going to give us 22. Dividing by negative 11 on both sides, we end up with x equals negative 2. All right, now we have to decide which one of these we're going to use. This has a couple of negatives in it. This only has one, so I'm going to choose the second. So I'm going to have 5 replacing the negative 2 here, minus 4 times y equals 6. 2 times negative 2 times 5 is negative 10, minus 4y equals 6. Adding 10 to both sides, we get negative 4y equals 16, divided by negative 4 on both sides, we get y equals negative 4. So the answer to this systems of equations is going to be negative 2, negative 4. Thank you.